dash me some 30 minutes of your time. And then better call. No problem. We will still get to do something, right? Now we also don't have board, so it means I can't write. Everything that I have to do, I need to talk. How many took a look at the video? Were you the same group I met last week online? You are that group. So it means we have gone through some of the things. So we said biometric means what? Last week we said bio means something, metric means something. Bio means what? Bio means what? And the metric means measurement. So we as humans, we have some traits that makes us what? Unique. And those traits are what we are referring to as your biometric traits. And then we are going to use those traits to identify each and every single one of us. Do you know how you walk is a trait? How you walk. Haven't you realized that sometimes someone will be about 200 meters ahead of you and you can tell that, the one I want to see the August in Equi. Have you realized that? Ah. Obi wɔ hɔ a na ne nanteɛ no yɛ funny paa te sɛ me deɛ yi bi. Nti wohu yɛ a na wohu sɛ ɛyɛ ɔno a. Haven't you been able to identify that person with how the person is walking? Even though you never saw the face, but how the person is walking, you identify that person. I don't know if you have heard about this phrase. Yɛsɛ nipa yɛ nim na awia na eduru anadwo a ɛnyɛ dɛ. Adɛn nti na yɛsɛ eduru anadwo a nsɔ kanea hwɛ n'ani? Ɔsɛ when the person speaks, even in darkness, you can tell that ɛyɛ ɔgɛst na na ɛkasa ɛyɛ ɔno a na ebedi saa nkwasasɛm mu. Meboa. Ah. So all these are what unique traits. And we are saying the biometric traits we have two. Physical and what? Last week. Physical and what? Physical and what? Okay, this what they show no. Physical and what? We have the physical biometrics and then the behavioral what? Biometrics. How you are walking, how you are talking, how you type, how you sign. All these are what? Biometric traits. But we are saying we are splitting it into two categories. The physical one, thumbprint, face, iris, those are physical ones. Then we have the behavioral ones. How you talk, how you walk, how you type, how you sign. They are all hot. Something that is your behavior. And at the end of the day, we are saying we can identify you by these what? These traits. Anyway. So today we are looking at biometric authentication. Biometric authentication. Computer science. Okay. So you know the authentication that you usually do. Username and what? Username and what? You enter the correct username, the correct password, you log in, right? So how about you provide us with the correct biometrics, you also log in? Wouldn't it be the same way? So the same way we authenticate people using their username and the password, we can use your unique features to what? Authenticate you. And remember, a username is unique and a password is also what? Unique. So if those two features are unique and we can authenticate you with it, it means that if we also have something unique about you, we should be able to authenticate you the same way. So basically, the authentication process is still the same, but the authentication simply means the process of verifying an individual's what identity. This time around, we are using what your unique characteristics, such as your physical or behavioral what biometrics. Now, what are some of the platforms we use biometric authentication in? We have mobile devices and the Okoto phone. That's a fingerprint in him and a facial ID in him. Na your pattern. Obeto. On the wall, Jesus said that. So these days, mobile devices are using what? Biometric authentication. We have banking systems. Banking systems. Obi a momo app na no de ne nsa tim so no a login. Obi a no de a kyerɛ n'anim no a login. Ɛnyɛ fɛ. Ha, ɔyɛ transaction ni wie na sika no so te ana afei wadwa line meboa. We have airport security. We have national identity systems. These days, every single bank authenticates you before a transaction what goes through. When you get to the banks, there are some banks they will tell you to thumbprint so that they can check for your Ghana card details. There are some banks they will scan your face and do the verification. All these are part of biometric authentication. We have healthcare systems. Unfortunately, for healthcare systems, they are now trying to implement it by merging the NHIA with the Ghana card data. So they are now trying to merge it. It's not fully done yet, but they are in the process. And then we have access control systems. For instance, our door here, we can check the lock to a biometric lock, whether thumbprint, voice, or facial. All of them they will work. So we also have access control. And without the door lock authenticating you, you can't get into this building. Without the lock authenticating you, you cannot get into what? Into this building. But there is a catch. We will get to that point too as well. Imagine you bought a biometric door lock. You have registered it with your thumb. What thou? What you are registered with what from class, what from Juma, what kufie, a be what thou what can't to so green, so lock it. What the hana joa from Phoebe by our dinner sato so a pippin. What the hana no echiao. Do you think your biometric authentication works? Ah. So even though it is secure, but there are some downsides to what to it. So we will take a look at that as well. So with biometrics authentication, we have two. We have verification and then what? Identification. Last week it was mentioned, but we didn't go into detail. We have verification and what? Identification. Now you have all done databases, right? Have we all done databases? Did we do entity relationship diagram? We have done that. Did you talk about chain notation? Chain notation, crow feet notation. Oh, the one that you draw the diagrams, you input the entities, their relationships, and their attributes. You remember you did that. Uh-huh. Now, in that, we have 1:1, 1:n. You remember that? Uh-huh. So if you take a look at the lecture notes, we have verification and what? Identification. Verification simply means we have a single template matching what? A single record. What does that mean? And what is also a template? Last week I mentioned what a template is. I told you that this is what? This is what? Oh, but where then? What there? Yes, I know it's a mobile device, but aside, okay, this is a hardware device, right? It's a hardware device. Now, what makes this device run or work? Come again. No, the motherboard is still a hardware. So the hardware comprises of all the physical components. But something needs to allow this to run. What is that? Thank you. The software. Now, when you put your fingerprint on this, the hardware picks what? The fingerprint. After picking the fingerprint, the hardware sends that fingerprint to what? To what? Thank you. The physical device is the hardware. Is that not the case? You have placed your thumb here. The hardware has picked your thumbprint. Once you put your thumb on the fingerprint scanner, it picks your thumbprint and sends that thumbprint to the software. Now it's the software that needs to take all the decisions. Are you getting my point? Now, the software that is supposed to take the decision, what I'm saying is, when you put your finger on the fingerprint scanner, it does not take a picture of your fingerprint. A picture of your fingerprint is useless to a biometric system. It's not that we take a picture of your fingerprint, then we put it somewhere. Later on, we take another picture of your fingerprint, then we go and compare. It doesn't work that way. When the sensor picks your fingerprint, it passes the signals to the software. The software now generates a template out of what? The finger that we have picked. Now, remember, the sensor will be able to pick everything here, but we don't need everything here. So last week I mentioned feature extraction. All the points here, we don't need it. We need some few points here that is unique to you. That is the only thing that we need. In mathematics, you did graphs, right? Now, to do this, to get the template, what the software needs to do is plot this, the picture that we have taken. The software will plot a graph on it to generate a mathematical coordinate from this. It's those mathematical coordinates that are unique to you that we are going to store as what? Template. So the template is actually the mathematical calculations that have been done on what? On what? Exactly. Your thumbprint. Are you getting my point? So we don't store the picture of your thumb, your face. We don't store an audio recording of your voice. We pick it, then we transform it into what? A template. So in the database, what we have there is not a picture of your face. It's not a picture of your thumb. The template itself is a mathematical representation of what? The actual what? Image that we took. Are you getting my point? Now, in systems, when you are new, we say that you are registering on the platform, right? In biometrics, when you are new, when you are now coming on the platform, we call it enrollment. We don't call it what? Registration. We call it what? Enrollment. So when you buy the phone new, the phone doesn't know you. It's blank. You are now going to set up. That setup that you scan your face, you turn your face around, you put your thumb on the fingerprint sensor, you turn it around so your entire finger is captured. That is the process of enrollment. You are registering your biometrics on what? On the device. So enrollment simply means capturing your biometric traits and transforming it to what? The template. That is what? The enrollment. The first time. So when the NIA was going around, if you were watching their press briefings, there are times that they will come when they are briefing the press, they will say that we are going around the country to do enrollment. So some of their machines, they call them enrollment machines because they were only used to capture the records and store it, nothing more, nothing less. Are you getting the picture? And we are saying that the authentication is two: verification and what? Identification. When your phone is new, you do what we call the enrollment. Is that not the case? After enrolling, the phone only stores a single biometric, which is for only you. Are you getting my point? The biometric stored is for only you. So the next time you pick the phone up and you want to log in, when you put your hand on it, the new templates that we take, we only compare it to which one? Exactly. The one that we took during enrollment, we compare the new one to that. And if it is matching, we what? We allow you to what? Get access to the device. So that is what we call verification. Simply matching one to what? One. And then on the other end, we have identification. 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 Now, for identification, that is where 1:n comes in. And I said 1:n means what? One to n means what? You see, and we can database as a media example. Thank you. One is to n simply means one to what? In database, when you see one to n, it simply means the relationship between the table at the left and the table at the right means one is to what? Many. Yo. So identification is one to what? Many. Now, when you go to the bank and you want to perform a transaction, when they put the camera on you, what do you think happens? It will scan your face and it will do what? Come again. So it needs to do something before the comparison can take place. No, no. So it scans your face, compares, but before it does the comparison, remember the face that we have scanned, we can't compare that image to what we already have. We need to transform it again into a template and go and compare it to the existing what templates. I just want you to get it clear in your mind that we don't take one picture. It's not like we have a picture here, a picture here. Me, I heard two in oh, me, they are so oh, almost say, oh, you know. That is not how it works. That template that we generate is a unique mathematical code for you. So whenever you try to log in again, the new template that we will get should be similar to the old one. Say, they say you're left and right, so you know, there. Take a Ghana card and your money pin, Kaukra bear 4 and 5. Me boa. Because we be on semi pa. Ono be beje. Na me suma beje. Me akure anso metimi ababiem. Semi beje bi. Wo be hweme ni obi. Oh. O sene pa ba senye ono mo ma no foforo. Enye no anu no. Na ka kura Ghana card bear 4. Ka FBI for buy nka me suma yirem. But you get my point, right? So it transforms it into a template, then it will go and compare. Now, the only difference between verification and identification is this time around, the NI database, it is not only you who is in there. So when we pick your picture and transform it to the template, we need to compare it to the entire what database. So now it becomes one to what? One to what? Now, because the NIA wants it to be fast, they take your Ghana card pin, then they will key it in. So by the time they scan your face, the NIA has already sent a template of that pin. By the time they put the camera on you, a template of that pin is already in, waiting to do what? Verification. No longer what? Identification. It is waiting to rather do what? Verification. The identification is when your template needs to hit the database, go through the entire records to find you. Are you getting the difference? So verification is me looking for you using your template. Sorry, identification is me looking for you from a pool using your template. And then verification is me looking for you or me checking whether this is you by comparing it to only one other what template. Are you getting the difference? So that is the only difference between verification and what identification. So under biometric authentication, we have verification and what identification, and these are the clear differences between them. And then last week you also mentioned that we have what we call continuous authentication. Imagine your banking app. When you log in, I have about $1 million, so I've logged in. Imagine that after every 5 minutes, the system wants to make sure that or getting it to log in, yen checking where say on one, when you phone into one or being five, and I'll be in the phone or traffic, you also have a transfer in the sicker. Have they taken your phone in traffic before? Yen fair be that. Yeah, yeah, but when I was a student, someone did something to me. Now, we call that continuous what? Authentication. Every 5 minutes, we will tell you to enter your username and your password or account number and password again. Every 5 minutes. Imagine the Momo app. Every 2 minutes, you are supposed to confirm whether it is you or not by entering your PIN again. I think I've heard it. Go on, now, how about we have a way of doing it without you knowing about it? In fact, your mobile phones actually knows you. If you give your phone to someone to use it, your phone knows. Are you aware of that? You are not aware. When you actually give your phone to someone to use it, your device can tell. Let me show you how. Let's use the mobile money app as an example. When you use the app continuously for about a week and the behavioral biometrics is going at the background, do you know the application is learning how you are using it? The application is actually learning how you are using it, how you scroll, how you log in, how you do transfers, how long it takes to do a transfer. The application is recording all these. So if I log in and I pass the device to him to do a transfer, maybe for me, when I'm trying to do a transfer, it takes about 70 seconds to get a transfer done. That is the minimum that it will get me to do a transfer. It takes me about 4 seconds to scroll to the end to click on transfer. The app knows. Since I have been doing it continuously for some time, the template of that is a mathematical calculation of how I scroll, how long it takes me to get down there, how long it takes me to what? Do the transfer. And in mathematics, we have something we call average, right? So your average speed can be calculated during this. And when you do this for 7 days, we can find an average of that. So if something is fishy is going on, it means it will not fall between the average for the daily, average for the weekly. It means something is going wrong. So if I pass my phone to him and he tries to do a transaction and in less than 40 seconds he's doing a transaction, what does it mean? What does it mean? It takes me 70 seconds. Now it is taking him 40 seconds to get a transaction done. What does it mean? Exactly. It means it is not what? The right person. So there are these banking apps that can actually block a transaction depending on how long it takes you or how fast you type the account details. So if you have realized some of them they don't allow you to enter an account to copy and paste an account number. You need to type. There is a reason for that. They can actually block a transaction based on patterns. It takes this guy 30 seconds to type an account number. Because you have gotten access to the account and you want to do it quick, it is taking you 10 seconds to type an account number. The transaction will never go through. Are you getting my point? And that is what we call continuous authentication. Just the patterns of how you are using the system can tell that the person who logged in 5 hours ago is still the same person who is using the platform and not another person. We call that continuous what? Authentication. Now, continuous authentication is also used in prisons and in large industries. Clocking system. We have some factories. Someone will come and clock 7 a.m. or clock we are no affect no appear. No akoya de fofora mo be 10 na no aba no abe adwuma be 3 hours bi no akon no abe clock out no ko. In the large industries, they use behavioral biometrics to do continuous authentication. Every single worker or staff, they know how they work. They know how they behave within the confines of the place. So the cameras around that are watching. They are actually doing what we call continuous authentication. So when you come and clock and the whole day they don't find any of your behavioral traits in the building, what it means is you clocked and you left because they can actually track you throughout the entire day using your behavioral biometrics, how you are walking, how you do your parking, how you do your lifting. All these are biometric what? Traits. Are you getting my point? So that is what we mean by continuous authentication. And the fun part is when we are using behavioral biometrics to do continuous authentication, you don't even realize it. Instead of telling you to always enter your password every 5 minutes, How about every 5 minutes we check your scroll behavior? Every 5 minutes we check how it takes you to do transactions. It can be done without your knowledge, right? That is what we mean by continuous authentication. Now, there is a table that gives you the complete differences between verification and what? Identification. That table is in page 5. You can also check it out. Any question on this before I proceed? Yes, please. Okay. Now, please, I'll come to you. When you bought this phone fresh, I said, what do you do? I had your registration. Oh, you did enrollment. Now, that enrollment that you did, the template is stored somewhere here on a database, a secured one on this. What your banking app needs to do is, you know how an API works, right? Your banking app has a direct communication with the operating system. So your banking app can tell the operating system the biometric template that you use to authenticate this device. I am about to take another template. So your banking app will actually scan your face. When the scan is taken, your banking app will transform it into the template and ask the operating system, does this template match the template that you use to access this device? Are you getting my point? Your operating system will respond a true or a false. If it's a true, what it means is the one who is trying to log into the banking app is still the same owner of what? This device. Now, before the banking app, they do that. They tie the device to the app. Are you getting my point? They tie the device to the app. So when you are the first time you are registering on the banking app, there are certain processes that you will go through. The reason why you go through those processes is because they are tying the device to the banking app. So every time you authenticate the app with the device, they get to know it is you. Are you getting my point? Mhm. Please, your question. I'm coming. Me pa cho kasa kese ma. Okay. So the face ID is actually a 3D map of your face. The ID actually throws a high beam of how do you call it? How do they call it? Laser beams. It throws it on your face. I don't know if you have taken a look at it. There are times in darkness when you turn it, you can see some red. Yes, those are the beams. So it can draw a 3D map of your face to authenticate you. But here is the catch: it doesn't take your retina, but it actually knows about your retina. That is why you can do it in a way that if you have closed your eyes, it won't authenticate. But if you have opened your eyes, it will authenticate. If you have opened your eyes without the black part showing, it won't authenticate. There is a possibility that the person will be able to access it. So we will get there. We have false acceptance and false rejection. We will get to that part. Yes, sir. If I don't know. Come again. The uh-huh. No, pass key is like a different thing. The behavioral one is like it's the same as relogging in multiple times. But this time around, it happens without you knowing about it. Are you getting my point? Aha, the background. Come again. So every single app that you have on this device has a database on the device as well. Do you get it? Exactly. 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 Come again. There is no way you clear that. Depending on how the application was built, they don't really store it in cache. It's stored in an SQLite database, which you can't find on the device, but it is there. So when they want to continuously authenticate you, they go to the SQL to do that. No, on your device. How come? Mhm. Your okay. So we have a downside, so you get there. Uh-huh. Please, there is one thing that you should always know. You know SQLite, right? It is something that is very important to software developers. These phones that you have, every single application on the phone has its own SQLite database here. Every single application on this phone has its own SQLite database. If you have realized, there are some of the applications you use for 1 year, then you clear the cache. Sometimes when you go through the application, the cache that you cleared is like it has been able to come back. Have you wondered where it was coming from? Come again. Not the cloud. The database is on the phone. It's not in the cloud. The SQL database that your application is using is actually on your device. Come again. Now, there is a difference between a cache and then a database. Remember, database stores it permanently. The cache only stores it for some time. You can put a timer on the cache and it will clear automatically. The database, what is in there, is stored permanently. That is why some of the applications you can actually authenticate yourself offline, even if you don't have internet. You can log in. I don't know if you have realized that. There are several applications you can authenticate yourself, even if you don't have internet. Thank you. What it means is there is an SQLite database on your device which has your what? Your logins. So if you are offline, the login is done through that SQLite what? Database. Please plug it for me. Uh, through the SQLite what? Database. So please keep that in mind. Is there any other question? Mhm, mhm. Okay. Now we have algorithms that we use to generate the template. Just like hashing password. We have several algorithms we use to hash passwords, right? We have MD5, we have SHA-256, 182 or 186. There are several of them. Is that not the case? Now, if I can talk with the operating system, I should be able to find out what exactly you are using to protect what you have. Do you understand you have done operating systems, right? Oh. Did you do scheduling algorithms and those ones? Operating system scheduling algorithms. Did you do that? Okay, so in the operating system communicates directly with the hardware. Are you getting my point? So when you build an application and you want to talk to the hardware, you go through which one? You go through which one? We said the operating system has a direct communication with the hardware. If I build a platform and I want to communicate with the hardware, I go through which one? You go through the operating what? System. To use the sensor, the sensor in the device. To use it, you need to communicate directly with the hardware. Remember, I said this hardware device is the sensor. So to talk directly with the hardware, you need to tell the operating system that I want access to the fingerprint scanner or the facial recognition scanner. Then the operating system will give you access to that. So the same way that the operating system will give me access to the hardware, the operating system, if I am considered to be a right tool, it will grant me access. That is why they verify applications at the Play Store and then the App Store, so that whichever application is requesting for access will not be an application that has been built somewhere and the application is coming to what? Falsify data. Are you getting my point? Any other question? Thank you. So it's actually let the operating system handle it because it has trusted the operating system. That is why your first time of using the app will be tied to what? The device. So if you have realized there are some of these mobile banking apps, this is my phone that I use always to access the mobile banking app. When I try to access it on another device, I can't use biometric to authenticate. I can only use my bank account number and the password. If I have forgotten the password, they will tell me to go and use the other device that has been tied to the account. It happened to me somewhere last year. I lost my phone. I got a new one. I was trying to set up my banking apps. Then I realized that because I have been using biometrics on the other one, I actually don't know my password to my bank account. And I can't change it too. So I had to go to the bank, fill a form for them to assist me. When it was changed for me, I got an SMS. I did some form again. Then I downloaded the app, did the installation. And when I was doing the reinstallation, that is when I realized they tied the app to the device. So whenever you change the device, you can't log in with another one to authenticate biometrically. Are you getting my point? Exactly. Exactly. Now, software, please, where are you? Software, class rep for software. The class rep is not here. You are the class rep for software. Okay. I am actually recording this. So later I'll share it. The part that you missed, then you can cover there. Okay. Now, what's your name? This is Elvis. Do you know him? Elvis, in fact, in fact, almost sorry, no more. Oh, sorry, no more. In fact, Elvis. No. In fact, Elvis, we are only for money for one year family. 1 year family. Now, Elvis is a vibe coder. The whole class, vibe coders, opening. Now, we are building an app. We want to be able to print receipts for customers after their purchase. Say, wait me have vibe coding. I can't we vibe code and a receipt printing app? Very simple, right? Oh, don't tell me you don't do vibe coding. Don't you do coding, programming? Now, me can you the software group, don't you do vibe coding? Now, we have been able to build the application. The application is built. We said the applications will do what? It should print what? The application is done. Oh. The moment a customer makes an order, the application runs, but it sends SMS instead of printing the receipt. It's not like the application is not running. Oh. When an order takes place, It does everything correctly. But instead of it to print the receipt for us, it sends SMS. Is there something wrong with the app? What is wrong with the app? Me and I'm system analysis. It was not me. Okay. In system analysis, you have functional and then non-functional what? Oh. The functional requirements are the things that the system is supposed to what? Do. We want the system to print receipt. That is a functional requirement. But at the end of the day, the system is what? Sending SMS. It means the system is running, but it's not meeting the requirements that was set ahead of what? Implementation. Have you done software testing? You have done software testing. Okay. So when do you have a bug? When you say you have a bug, when do you have a bug? Computer science has done software testing. See, I'm moving one frame. Software, you have done software testing, right? Okay. And you're going to say yes or no. Who taught you software testing? Eh? Question anybody or who journey? When do we have a bug? Oh, yeah. It's in how. When do we have a bug? Who taught you software testing? Come again. Computer science, software. When the system behaves unexpectedly, you have a bug. A bug is not only when your code is not running. If your code runs and it is still not behaving as you intend it to, you have what we call a bug. So it is not only when you see an error in the terminal or the application goes down that you have what? A bug. Sometimes the application runs all right, but it is not doing what it's intended to what? To do. That is also considered to be what? A bug. So in software testing, we have categories of bugs, we have categories of errors. Anyway, now this application we wanted to print receipts, but it's rather doing what? So what do we have? Thank you. We need to test the application to make sure that we have been able to sieve all these bugs. Is that not the case? The same thing applies to biometrics. Even though you trust that you have vibe coded the thing completely, you still need to make sure that it what? It works as it is intended to what? To do. So biometrics, we also have some metrics that we use to test it. Now, for the software group, I'm sure for you, you can relate to this example. I have seen people build platforms, e-commerce platforms. Their payment integration, they do the payment, they forget about receiving the response. The response comes back with a status of 200, right? Which is a 0 and a 1. Now, if you send a payment request, sometimes for them in their head, when the request hits the API is supposed to handle it for you, right? The API will handle it all right, but it needs to send back what? A response. And that JSON response, if you decide you don't want it and you don't intercept it, if a transaction doesn't go through, you will never know. If it goes through to you will never know. I have seen people build platforms and they send a request, they don't receive the response. When you are doing it in development mode, you are using testing keys. Once you are testing, it will be going all right. And there's some oh, transaction successful, alert about now when they deployed the platform, what they didn't know was that because they were not taking any response back, if the transaction fails, they can't tell. If it goes through, they can't tell. So what it means is whether the transaction passes or fails, the order will go through. Yes. Now it was deployed. So the customer started complaining that they have 100 orders. They are expecting 100 payments, but now they have 75 payments. So it means some of the money is missing, right? But the problem is you can't tell which one is missing. Are you getting my point? The application is working as it's intended to do, but something is going wrong somewhere. So testing is something that is very what important to make sure that what you are expecting at the end is actually what the application is what is doing. It applies to biometrics too as well. You want fingerprint authentication and you only want it to authenticate Augustine. Meanwhile, the fingerprint is authenticating him as well. The example that I gave earlier on. You want to buy a fingerprint door lock for your room, your bedroom. You close lectures when you went, thumbprint on it, pa green, a B, where we want to pa a sound of red, I took me boy. Tell Danny, oh dear. Oh, Hannah, Joanna Brownway. Do Hannah didn't settle so pepe in a B. When it's in or Tewakunya was a Bramichia. Did your fingerprint authentication lock work? Did it work? It worked, right? But what happened? Obi remind said the Uchim. Uh-huh. So we have some metrics that we measure biometrics on. And those metrics we have accuracy. That is how accurate is the system able to identify authorized users. You know the room, you are the only person authorized to enter that room. At the same time, everyone is coming in. Is the system accurate? Is the system accurate? Okay. So we have accuracy, we have false acceptance rate. False acceptance rate. Now, false acceptance rate refers to the probability that an unauthorized person is incorrectly accepted by your biometric system. An unauthorized person is what? Incorrectly accepted by what? The biometric system. We all know that this one is not mine, right? It's not mine. And we said it's the probability that an unauthorized person gets access or is authorized by the biometric system. Is that not the case? It's not mine. Are we all paying attention here? This is not mine. Am I authorized? Am I authorized? Fingerprint. One, two, three, and four. Oh, I pick it. I mean, are you getting my point? It's not mine. I'm not authorized. One, two, three, four, five. The fifth one, now pick it. Someone asked the question here about this thing. You are the one, right? I'm not authorized, right? But it has accepted me. How many tries did I go through? Five. The fifth one was the one that what got through. That is what we mean by false what acceptance rate. If I try 5 times and I'm able to accept it once, what happens if I try 100? The false acceptance rate goes up. I get to my point. So we have a formula for calculating the false acceptance rate, and that is the number, the total number of unauthorized acceptance out of the total number of what requests. So this time it will be one out of what? One out of, if I try it 100 times and it appears that I go through 20 of the time, it will be 20 out of the formula is there. Are you getting the point? Okay. And then we have what we call false rejection rate. False rejection rate. The opposite of false acceptance is what? This one is mine, right? I'm out. Still, in fact, okay, after BA. How many times? Are you getting my point? I am the authorized what? The authorized what? But at the end of the day, I have to try how many times? And the fourth one, how many times did it go through? So it will be one out of what? So the false rejection rate refers to the probability that an authorized user, when you are what? You are authorized. An authorized user is incorrectly what? Rejected. Phone is out there, but phone is only. Are you getting it? Okay. I'll come to the reason why this happened. I want to combine the two. Then we also have what we call equal error rate. Equal error rate. How many did economics here? Economics. Not the university economics, so SHS economics. Okay. Now, we are sure someone say pila echi o hume. Because you know so I have one so hume. Now, take a look at this marker. But you want hume no French what? Take a look at this marker. Hmm. I remember. We just also hume. Enya take a look at this marker. It's straight, right? Let's take it that false acceptance is here, false rejection is here. False acceptance is here, false rejection is what? Is here. When the marker turns this way, what does it mean? It means one of them is now heavy and the other is what? Light. So if false rejection is here, it means false rejection has now what? Increased. So it has more weight than false what? Acceptance. The same way when it turns this way, it means the right hand side too has now what? Increased. And the left hand side has what? Reduced. Are you getting my point? Now, when it is split, what does it mean? What does it mean? So those who did economics, this is what we call equilibrium. It means what we have on the left is equal to what we have what? On the right. So it means the false acceptance rate and the false rejection rate are what? Equal. But are you getting the point? Okay. Now, to the reasons why false acceptance, false rejection rates happen. Who uses a Samsung phone here? Oh, Samsung. Samsung then. Me that's a patch of a oh, minimum say Samsung. Please pay attention here. This is S what? This is S25 and this is what? This is Huawei Y9. S25 and Huawei Y9. Which one is expensive? The S25 is more what? Expensive. Papa is car on which one so? Yeah, better do only be a man near the biometrics account. Near my false acceptance na posro. Padana junior will near kofa. Okay. Now, there is a reason why this is more expensive. There is a reason why this is more expensive. The chipset and the sensors are modern. This accepts and condones heat more than this. Are you getting my point? The sensors in this are the current generation sensors. The sensors in this maybe 2 years ago generation sensors that has been upgraded a little bit. So definitely this is going to be more expensive than what? Than this. Now, remember I told you this can resist more heat than this. Is that not the case? So what it means is, if the two of them they are all warm, this sensor for the fingerprints can authenticate me, but this one will not be able to authenticate me because it cannot stand what? Heat. Are you getting my point? The camera sensor in this is better than the camera sensor in what? In this. So one of the reasons for false acceptance rate and false rejection rate is what? Sensor quality. Yɛn nyinaa nim sɛ adeɛ no yɛ $200. Nko ara wode a wo sɛ woyɛ the fingerprint sensor no so wokɔ akɔtɔ $50 deɛ no. Are you getting my point? There is a reason why the other one is 200 and one is what? 50. Sensor what? Quality affects what? False acceptance and then false what? Rejection. It is a sensor in here. Like this one that I'm saying, if the sensor cannot withstand heat, what it means is the probability that when this device is warm, I'll put my hand on it and it will accept me falsely is very high than what? Than this. Please, are you getting it? Then the next one is what we call threshold. Unfortunately, no board for me to even do illustrations. What we call what? Threshold. Remember, I told you false acceptance and false rejection are what? Probabilities. The entire biometric ecosystem is based on probability, mathematics. Now, we said when you buy the phone fresh, that turning around and the thumbprint that you do is called what? It's called what? So, unfortunately, you were not here. It's called enrollment. In biometrics, we don't do registration, we do what we call enrollment. The first time that you are giving us your template, we call it what? Enrollment. Now, when you do the enrollment and we store it as what? We store it as what? So we are saying that for the benefit of those who are not here, when the sensor picks your fingerprint, your face, or your voice, we don't store them as raw copies. We transform them into what? Template, which is a mathematical representation of what? The image that we have what? Gotten. Now, in mathematics, a picture of this, you can draw a graph on it and plot it. So the mathematical representations like coordinates on what? On your thumbprint or your fingerprint that we store. There are some unique points here. We store those coordinates as what? Your what? Templates. Now, when that template is stored, anytime you pick the phone, what happens? You put your fingerprint on it again. A new template is generated and compared to what? The previous one. Now, during the comparison, there is a 50% chance that my template is similar to this guy's template. Are you aware of that? There is a 50% chance that my template is similar to what this guy has. That is what we call the threshold. Whoever it is who is architecting the system decide what the threshold should be. If the threshold is 50%, what it means is false acceptance rate will be what? Will be what? False acceptance rate will be what? It will be high. Because if I pick this guy's phone and the threshold for the authentication is 50%, what it means is if my thumbprint is 50% similar to his, I'll get in. But if the threshold is at 95%, there is no way that my fingerprint can match his fingerprint 95%. Are you getting the point? What it means is the false acceptance rate will what? Will reduce. Because the threshold now is set what? High. So it's either him or no one. That is how come we have some platforms that identical twins, they can all authenticate for each other because the threshold has been set a little bit low. So the two of them cannot authenticate themselves. That is the only reason why Apple included the laser projection in the Face ID so that it can what? Reduce the false acceptance what? Rates. Are you all together? Now, we also have what we call poor biometric templates. Last week, I used some farmers as an example. Which farmers did I use? Cocoa farmers. Now, when they go to the farm and they get the cocoa bean, they crack it open, then they use their fingertips. No, I am back, no, I watching it. No, I bought second one, no, I no, I watching it. No, I bought third one, no, I no, I watching it. And then some right and then yeah, no, I change it. Or the left no more, no, they go, no, I to share on actually. Because they had been doing that for so many years. Take a look at your finger. Take a look at your fingertips. Wow, they are share. Now, geography students here. Is there any geography students? Who? Oh, who did geography here? Aha. In geography, we have what we call contour lines. Do you remember it? Now, take a look at your fingerprints. It is similar to what we call the contour lines. And you remember in geography, you can actually do mathematical representation of a contour line. It's the same thing that applies here. Now, you see the lines move from here and ends at the other end. Take a look at your finger carefully. It starts at here and ends at the other end. Now, for the cocoa farmers, those who have been doing it for long, the line from here to here is not there. The entire place is smooth. The entire place is very when we see a cat will be able sakura and all the sun of the one. That is how it feels. You can't feel anything. So what it means is the fingerprint record that you pick for that person, you can't get any template out of it because there are no unique patterns here. Now, the funny thing is some of them, the right hand, you will not get any. The left hand, if you are lucky, you will get these two. The rest of the three, you will not get. So for some of them, there is no template for fingerprints. So when they go to the banks and they want to authenticate and the bank is only using fingerprints, forget. Are you getting my point? But remember, there are so many different templates on the Ghana card. Face, ears, fingers, iris, they are all there. So if this is failing, we can depend on what? The others. Are you getting my point? Now, we also had the ladies, those who work in the chop bars, the cooking pot, when it is very warm, aduane no hu na aben no, they have to use the microfiber cloth to, to bring it. They would rather use their hands. Or the sensation or the sensation no atomasi. Now, remember, they don't do this once, they do it continuously. So as time goes on, not just the cell that is dead, the entire print here is gone. There are some of them back to it again. When you take a look at your fingerprint, it starts here and ends here. There are some of them, it starts here, ends somewhere here. In the middle is very smooth. Then the other side, the fingerprint continues. Because they had been doing it for what? Continuously for so many years. I remember there was a lady who came, no fingerprints, left or right, not even one. And the enrollment officers didn't know. So they kept on trying to get fingerprints. It was not working. So when I was called and I went, I realized that there is no fingerprint that we can get to generate a template. So it can be done. Now, when we started asking her questions and we were even playing with her, she said, "Me me ti hey me nsa no me nti hwee o." And and when we asked her that question, she was like, "Oh, mommy, pani o me nsa no kra me nti." She actually used the earring to show us she doesn't feel it. Are you getting the point? So the quality of the scan will determine also what? The false acceptance and then what? The false rejection rate. Are we all good? Please, is there any question? Is there any question? Okay. Now, this also leads to what we call failure to capture what rates. When we are doing enrollment and this is not there, there is no way the enrollment can take place. You have bought a new phone, you want to use your fingerprint and there is no fingerprint. Can you register it? Enrollment will not take place. Okay. Now, so you just keep the fingerprint. So you use the other features. There is no way you can get it. Woman 100 years to cry. Oh, yeah. Mhm. Now, the threshold that I was talking about. Some of you, how many went to do the Ghana card and after doing everything, when the enrollment process was done, they told you something happened, so come back in a month time or a week time. When you know, and then you now, there is a probability that your template will match someone's template about 40%. Your template can match someone's template about 40%. And when that happens, it means you can't get the card. Adjudicators need to find out whether it is you or not you. And remember, those who did the registration during first time, 2008, 2007, thereabouts, they did registration for citizens. Someone was 5 years. We took their fingerprints. In 2019, you did the registration again. The system will automatically match the two of you. That there is a possibility that it is the same person. Your template is matching this person for about 70 or 80%. Some goes as high as 99%. And when the adjudicators go through, you can tell that the person did the registration in 2007 as 5 year old, and now the person is above 18. So they merge the two templates for you so that you can get your card. Now, there's a probability that a male will match a female. It is there. It is there. So the threshold determines all these things. Now let's move to databases. We don't have a specialized database for biometrics. Remember, we said we store the templates. We don't have a specialized database that is designed to store biometric templates. The regular databases that we have been using, whether relational or no relational, MySQL, Oracle, Postgres, and so on, they are the same database that we use for what? Biometric what? Systems. Are you getting my point? Okay. Now, for biometric systems as well, please pay attention here for me small. We have online and then offline. The offline, the templates are stored on the device. That is how come we have attendance systems that can be fixed on this wall. And the class will be dedicated for you to mark your attendance. Every time when you come, you don't need to connect to the internet, it will mark you. The offline, the templates are on what? On the device. The device has a database, an SQL database on it, which will store what? The template. And then we have online whereby there is a server somewhere which stores the template. And when you are trying to authenticate, it will go and check online before a response is what? Received. Just like how we build platforms, it works also the same way. So we have some challenges in data collection. I'll allow you to read that. Environmental conditions, just like we mentioned last week, it's also in there. And then we have privacy concerns when it comes to biometric data. Privacy concerns when it comes to biometric data. Now, imagine the NIA took our records and they shared it online. How many Ghana cards will you get? Our biometric records are shared online. How many Ghana cards do you think you can get? Eh, what's it? Only in person can say. Eh, Kabana nke FBI for buy you know hwen. Sami man fa biometric records anya anje sika na ngum account mu a obi de we de be. Are you getting my point? So we have privacy what concerns. When you are collecting data, you need to get what? Consent. It's like you are doing research and you are gathering data. You need to get what? Consent before you what? You gather the data. And you need to make sure that the data you are gathering is what? Well protected and what? Secured. So that is where data protection agency comes in. You all know data protection agency, right? So for Ghana, we have a data protection act that is supposed to allow companies to protect our data so that they don't share it anyhow. Because the university has your records, should they share it online? Should we share your results and everything? That is not supposed to be so. These are all protected by the Data Protection what? Act. So it leads to if I tell me by the It's, these privacy concerns, if it is not well taken care of, it leads to misuse of biometric data, surveillance, and what? Identity theft, just like I was saying. Or maybe I was here. Oh, all right. So we will end the meeting here. The last part of it was the processes that we go through to what? To register stages of what? Biometric systems. We have enrollment, data acquisition, pre-processing and feature what? Extraction. And then we have template creation, template storage and matching. And it's under matching that we have identification and what? Verification. And the feature extraction, just like how I explained it, when the sensor scans this, we don't need everything. We don't need to store everything here as a template. We need to store the unique words, coordinates here as the template. That is the features that we what we extract. Yes. Mhm. Okay. So the template creation is actually done by an algorithm. So we will take a look at the algorithms. They have their drawbacks and then they have their benefits. So depending on the algorithm that you are using, that will determine how feasible your issue is. And please, one last question. He is asking that is it possible that you will generate someone's fingerprints, then you wear it on your thumb to go and authenticate a system? We will get there. We will get to that point. There are ways that the sensors can detect that. We have something called liveness detection and so on. We have how do you call it? Multi-factor authentication. So you authenticate by thumbprint, it will give you a phrase for you to speak. Are you getting it? So we will get to that end. We will get to that end. It is possible to do it, but there are things that have been put in place to prevent that. So how you see it in the movies in reality is totally different. Uh, Depending on the sensor what quality. All right. So God willing, same time. Now there is an issue. We only have 1 hour 30 minutes to meet. 1 hour 30 minutes. To me personally, I can't cover the theory and the practicals because I wanted us to at least have one practical session, even if it is fingerprint system that we are building or facial recognition. We build it together. I know you can vibe code it, but I want us to do it in a way that you, even if you are doing it on your own and you are vibe coding, you know where to start, you know where